Alright, this is the last video for chapter 4, and we're going to look at nuclear equations. So before we were talking about nuclear decay or radioactive decay and radioactivity and the different kinds of particles that we were looking at there. Now we're going to look at the equations that you write behind these when you decay from one element into a different element. So that's kind of what a nuclear reaction is. Okay, this is where you're going to change one element into another element. Along the way, sometimes you're either going to lose particles or you're going to change one particle into a different type of particle. And sometimes it is both. So the first type of nuclear reaction we're going to look at here is an alpha emission. And remember, again, we're changing one element into another element. Okay. Well, an alpha particle that we looked at before was a helium-4 nucleus, so 4He. Sometimes it's also nice for these to write the bottom number, and that one is 2. Remember, it's 2 because it's He. So we don't have to put that there, but a lot of times it'll make these a lot easier if we do that. You'll also sometimes see alpha particles written like that. Okay, alpha emissions are usually with heavy particles. So these nuclei that are extra heavy, okay, will sometimes emit an alpha particle. And what happens is here, your protons and neutrons, or a few protons and neutrons, are decreased or emitted, and they are emitted to increase the stability. And we are losing exactly 2 protons and 2 neutrons because it's a helium-4. Okay, so an alpha emission reaction would look like this. If I have 210 polonium, okay, it is going to decay. So what I begin with on the left side, what I'm going to end with is going to be on the right side. So polonium 210 is going to decay. Okay, and if I look on the periodic table, I know that polonium is 84. Like I said, it's helpful to write these bottom numbers actually when we do these. Okay, now it's going to tell me that's going to alpha emit. So I'm going to write 42He. They have to tell you what kind of emission we're dealing with or what kind of radioactive decay we're dealing with. Okay, so this is my alpha particle. So if that's going to be emitted, that means then what are we left with? So if I had originally 210 protons and neutrons, I lost 4 protons and neutrons total. So 210 minus 4, we're going to end up with 206. Okay, so 206 is my top number. Notice how 206 plus 4 equals my left side of 210. What we start with on the left, what we end with on the right. Okay, now how do I know what element this decays into? Well, I started out with 84 protons, that's polonium. I lost 2 protons to an alpha particle. So if I lost 2 of those 84, now I have 82. Look at my periodic table, 82 is lead. Okay, so again, that's why it's kind of helpful to write these bottom numbers because the left side should equal the right side. We call these our products on the right, what we're producing. Our reactants are on the left, what we're starting out with. Okay, and it's being emitted, so notice my alpha particle is on the right side, emissions. Okay, you're emitting that alpha particle, and then you're also ending up with lead 206. Okay, so that's an alpha emission. Now let's look at a beta emission. Okay, beta particles are pretty much electrons, so you'll see it written as 0, -1 E, or you'll see it kind of like a bee with a little tail. It's a -1 because electrons have a negative charge. They are the exact opposite of a proton. Since we write protons on the bottom, we put a 1 on the bottom and a negative to make it opposite. So what's going to happen here is you're going to have a neutron, okay? 1 up here because it's my proton plus neutron number. I don't have any protons because I have a neutron. And it's going to change into 1 proton, okay, and 1 electron. Now notice how 1 plus 0 is 1, 1 plus -1 is 0. So we're going to take a proton in my nuclei that I'm dealing with that's decaying. I'm going to turn that neutron into a proton and electron. And since protons and electrons are opposite, it's pretty much the same thing as having a neutron. So that's why we can change them in there. Okay? And what happens is then your number of neutrons goes down and you are emitting an electron from your nuclei or from the nucleus. So let's look at an example. Okay? If I start out with 14 carbon, and I know that carbon is number 6, put a 6 there. It's going to beta emit, okay, or beta decay. And again, they're going to have to tell you that piece of information. Okay, so since it is turning into something different, we're going to lose an electron. Okay, and we're going to end up now 14 I start out with. I didn't lose any neutrons or protons, so I still have 14. Well, I emitted an electron. All right, so and actually this number here is going to be 7, because 7 minus 1 is going to be 6. Your neutron turns into a proton and an electron. We emit this electron, which means I'm left with an extra proton. So your number of neutrons goes down, and we're left with an extra proton, which is why this proton number here went up. And proton number 7 is going to be nitrogen. Okay, we're looking at positron emission. So again, we're still emitting particles. Notice how these particles are being on the right side of my reaction. Okay. Now, positrons have the same mass as an electron, but are positive. Okay, so what happens here is we're going to emit something that looks like this. It's going to be 0, 1, E, or sometimes you'll see 0, 1 with a beta. Okay, what's going to happen now, okay, is that I'm going to have a proton, okay, that's going to turn into a neutron. And a positron particle is going to be emitted. So my proton turns into a neutron, and I have a positron that's emitted. And you emit this from the nucleus. You're just changing particles around here. Just like a chemical reaction with chemicals, now we're doing this with particles. Okay? So if I start out with 39 potassium, potassium's number 19, it's going to positron emit, or emit a positron. It's going to be 0, 1, B. Okay, notice how I'm now going to end up, okay, with my same number of total protons and neutrons. So I've got 39, but now I take my proton, turn it into a neutron, and I'm going to have a total of 18 to be argon. So I have one, notice here I have one less proton, but my total still stays the same. Okay, so it almost looks like that you lost a proton, but you really didn't lose it, you just changed it. Okay, you went from 19 to 18, which is 18 is argon. Okay, last two. We have electron capture. So this one's a little bit different. Notice how it doesn't say emission. Okay, you are capturing an electron, and how this works is they're an inner orbital electron. So an inside electron, we haven't talked about orbitals yet, but let's say an inside electron in my atom, okay, is captured by my nucleus. Okay, and what happens is this inside electron, which is 0, negative 1e, combines with a proton, and we're going to make a neutron. So when we make a neutron now, it'll look something like this. Okay, I'm going to have 106 Ag. Ag is 47. Electron capture. Now, my electron's going to be captured, so it's going to be on the left side. This is one of my reactants. Okay, I'm capturing that electron, and I'm going to turn into 106 palladium. How do I know it's palladium? 47 minus 1, which is 46. You can also look at it from the standpoint of we took a proton, we turned it into a neutron, which again in essence means that we kind of lost a proton, okay? And I'm going to have one less than what I started with. Okay, the last one is gamma emission. This is the easiest one, okay? Gamma particles, again, we talked about, are these high energy waves or high energy particles. Okay, these tend to, like I said before, occur with another decay. And the reason being that these occur with another decay is that a gamma particle, and that's my gamma symbol, is no mass. So it's 0, 0, which means really it's not changing anything. So it has to accompany another decay to change the actual element. So if I say that thorium 234, which is going to be 90, okay, is going to beta and gamma decay. So I'm going to lose a beta particle and a gamma particle and see what I'm left with. Well, I didn't change any of my total, so I'm still going to have 234. But I lost a gamma particle, which is nothing, and a beta particle. Okay, well, we look at the beta emission. That means I'm turning a neutron into a proton. So I've kind of got to gain a proton here. It's going to be 91. And look at that. 91 minus 1 is 90. And I'm going to have PD, which is 91. Or, I'm sorry, PA, which is 91.